Hello, everyone. My name is Serafim Bakalis. I'm a head of Biosolutions and a professor of their product technology at the University of Copenhagen. And I'm here to talk about biosolutions. And actually, it's a personal journey I want to talk about, a very personal perspective, and how we move about from biotheory to actual biosolutions. So I will start with who am I, introduction. I'm born and raised up in Greece where the sun is shining and the grapes are good. And this is one of the first fermentations and one of the first biosolutions people came up. Then I moved to the US, I moved to the UK, I lived in China, I lived in Brussels, and now for the last 5 years I've been living in Denmark. My background, most of it has been really around developing materials for products. That is foods, that's personal care products, with the idea being that you can combine materials with process to create structures, to create functions that consumers want, and that is really developing solutions. So how do we move these solutions to what nature gives us, to what biology? We should look back in time to move forward to address some of the problems we have. For example, if you look how people came up with products and solutions, we could look at feta cheese, one of the very popular, I believe, products, and one of the first recorded actually histories. One of the first recorded places where you can find the cheese making is actually in Odyssey, which is about 750 to 650 years before BCE. And similarly, to a similar time, you can see how people start developing plant-based foods, and which is very relevant today for a sustainability perspective. And here we talk about tofu, and the process are well established, and we're talking also about 200 years before this. So this is just gives you an idea that there's a lot of solutions out there. We'll use biology, we'll use fermentation to produce products that people enjoy and like for a very long time. Some of the other cases, how we're using this, then how we're using this knowledge to design future foods is through fermentation. And what we're trying to do here, because animal-based proteins have a very large sustainability impact, we're trying to develop structures, we're trying to develop textures that consumers want to eat. So this is Professor Dennis Nielsen, who's based here, and he's designing mixed fermentation processes to really come up with plant-based structures that consumers would like to eat. And that would be based to provide foods that consumers want and foods that they don't have a very big sustainability impact. A second case is about where do we use biosolutions is for cleaning. And if you see here, this is some of the work I've done. And this is what happens when you're trying to clean maybe the stainless steel oven or tray after you cook some protein. You can see the protein swells, it becomes softer. Then you have enzymes that will pick it up and then you clean. And here we're using enzymes, we're using biological solutions to clean. And why should we bother about this? Is because we're using an awful lot of water. Actually, there are about 200 million households in Europe. Everyone combined would do about 45 billion wash cycles, and each one using is about 50 liters. So we're talking about thousands of liters of water that we need to heat and use on everyday life. So reducing the amount, doing it at lower temperatures, it really helps. So we're trying to do that. And what are we actually doing is we're really developing small-scale measurements to understand the kinetics of removal of protein layers, so you can see a swelling phase and a removal phase. And then what we're doing is we're building models based on which we can really optimize and understand how enzymes, how biological solutions can help us. And I've done this work personally for about the best part of a decade. And after all of that, what happened a few years ago, I got been interviewed from Times about the success of how do we actually wash the dishes. And the only thing that the journalists remember is that my mother does not allow me to do the washing machine, to put the washing machine when I'm back home, even though I'm literally a world-class expert in the area. Nevertheless, just to move a little bit to slightly more exciting and I would say different ways we approach the problem is when we start needing what are the societal needs, in terms of food, we have significant environmental impact and we need to try to reduce. But also in terms of buildings, the materials we use for buildings have a significant impact. So actually 50% of the materials in EU are for buildings, and these account for 40% of the CO2 emissions. So what we're trying to do, we're trying to establish collaborations with the architects because they're building materials out of fungi and we're building food out of fungi. So we're really trying to collaborate to understand how could we build materials that could be used for foods or for buildings. Can you grow your own house, basically? So we're really trying to see how we can understand the structures, how we can use fungi to either convert them to tembe or to, to burgers, or to actually use them, for example, for plasters on the wall. So really the technology is the same and could be scaled. And the place which this takes place is actually not in Copenhagen. It's currently a small city, it's a port in the north of the island. It's called Kalundborg, and here is the heart of the manufacturing in terms of biological productions in Denmark and certainly in Scandinavia. So there's a massive expansion in the area. It's one of the largest biomanufacturing hubs, and we're talking about a significant investment taking place over the next few years, with obviously significant opportunities for job positions. And here what happened is we were asked actually to start developing capability there, developing and training people who know how the biology works, but also know how they can deliver solutions in the real world impact. So one of the interesting things about Kalundborg is that there's a symbiosis. So people start developing share resources, they share energy, they share water, they share materials across different manufacturing. And what we're trying to develop is really an environment where the students really benefit of this symbiosis, of this sharing environment to grow to something that is quite unique. So in terms of biosolutions, trying to build a little bit more, these are really solutions. We're not interested in theory. And these are multidisciplinary approaches to solve really complex problems: food supply chain, environmental problems around buildings. And here, the core of that is we're looking at what nature is doing. We're looking at biological processes or bio-based components to try to develop new solutions. This could be for agriculture, for food, for ingredient productions, for pesticides. And just to give you some of the solutions, there could be solutions for agricultural. This is, for example, upcycling side streams or developing biofertilizers. I already gave you some solutions about ingredients or producing new foods that are biological based, but also converting biomass, for example, into biofuels or really bioremediation and environmental solutions. So really the core of the science is the same, but the application could be quite wide and for different environmental sectors. So, and what we're doing is we're offering a specific MSc on biosolutions. And the idea here is we're trying to combine biology with the processing. And that is really what is needed, what is the society needed, and what the manufacturers are needed. Is needed people who know what they're producing, but know what is the effect of changing stainless steel into the actual quality of the products. And here we're talking about setting up a lot of the theory and a lot of the concepts behind the MSCs around what we call the double diamond. So we convert the problem space and the solution space. So we understand how what are the processes that you really need to drive to develop to come towards the solutions. And I think one of the key partners is that really one of the key points and differentiators, I would say, is really we're looking to build this program within the local ecosystem, which means a lot of large industrial manufacturers, but also quite a few smaller SMEs and startup companies. So we're really trying to connect the theory with an environment where the solution can be given. So in terms of the curriculum, what we're looking is at the 2-year MSc. The MSc is in KU, they're built in different blocks. So there's 4 blocks of MSc. So there's quite a few courses in the beginning of what I would call more theoretical, where there's a practical exercise, and I'll talk a little bit more about that. And on the second year, there is more space for the candidates to involve, to do research works, to do research projects, and engage with the industry. And I think one of the differentiators and what we've been really actually asked from a number of people to do is, instead of doing a traditional course with the theory, we're turning the courses upside down and we're trying to see, starting with problems and trying to see how do we build theoretical knowledge to address specific questions. As I mentioned before, there is a lot of interaction at different levels with the industry to make sure that the knowledge is really state of the art, but also it is relevant. So that goes from lectures, from visits, for case studies, for joint research programs. There's more information to be found, obviously, on the website. And then maybe as a concluding remark and a little bit on what is my interest in the area is really moving from biotheory to biosolutions. I came at a point in my life where I thought there's a lot of people doing theory, somebody should really talk about solutions. So for us, we're really looking at people who really want to make a difference, and that would be a differentiator. Also, in terms of solutions, we're looking from inspiration from biological systems. See what are the solutions that nature has given us, and how can we leverage it to address contemporary problems, environmental, I would say, to a large extent. And we're really looking at what some people look at all technologies. Sodium fermentation is really not a new technology. I mean, it is an odyssey. So we're also looking, one of the key parts is how do you adapt technologies to deliver real world solutions? And I think here a solution might seem easy, but then you deliver solutions to different regulatory environments. What does it mean if you want to sell a product in Japan, for example? What is the regulatory environment? What is the quality control? What is the supply chain? So really, we're looking at people who have a broad understanding or to provide a broad understanding across the supply chain to make sure it turns up to make a difference. And for me, the interest is to imagine the difference first, to really start imagining how would it look like, what would be the potential solutions, but also to make a positive difference, to have the tools to articulate, to be able to deliver in a real world, in a commercially successful business. So I didn't want to take that much of the time. I hope that gives you a good idea of what it is, and certainly more than happy to get in touch to ask any questions.